All right, I think it's time for start. Welcome all to Synchronicity Enfuser webinar. We will start off with a representation, which would give you some overall knowledge of how Enfuser works, and we have left some time for questions at the end of the webinar. So please ask the questions then. Please note that this webinar will be recorded. And the slides and the code examples will be available to you afterwards. We are Antti Leppä and Heikki Kurhinen. Hello. Both from Metatavo Oy. We are both software architects, and we have experience in multiple programming languages, but today's examples are all written in Java. I hope it's okay for all. We were both in team that created a Clean Air Road project in Synchronicity, and got quite familiar with Enfuser during that time. And now it's time to share some of that knowledge with you.
Yeah, today we are talking about this Enfuser modeling system, which is a air quality model created by Finnish Meteorological Institute, which combines data from multiple sources like sensors, weather forecasts, geographic data, and OpenStreetMap data that contains location and size of buildings and routes. And this data is then stored in a grid that includes forecast, real-time, and past data. And how you can get this data? It is currently open data. You can download it from the Finnish Meteorological Institute's online service that we can now show you. Here is the actual catalog, and it shows you some metadata of this data, but the actual data file that we are interested can be downloaded through VFS service. Here, and you can see a lot of XML data that gives you also the metadata in machine readable format about this file, but the actual file that we are interested can be found from the file reference link. It has also some parameters that we see later in this VSFS interface. There is the possibility to provide some parameters to download the certain part of the data. There is a bounding box, start time, end time, and so on, which are described here. The whole data file is quite large. It's over 2 gigabytes, so we are not going to download it right now because it will take some time, but luckily we have already done it yesterday. So we can take a look at the actual format. The data file that can be downloaded from the link that we previously saw is in netcdf format. That is a data format used to describe scientific data in large arrays. There are many client libraries for that data model. It is in at least in C, Fortran, C++, Java, and there is also other languages, but those are the officially supported ones. There is also many graphical tools besides these programming languages, and we are going to take a look one at this point, which is a Panoply. It is developed by NASA.
All right. Here we can see the Panoply's main screen. as you can see, we have opened Enfuser file. It's from last year, but it's still the same file, so it's quite okay. In this screen, we can see how the file is organized. It has multiple different variables, which some of them describe how the data is stored. This is the type, for example, 1D type. There's latitude and longitude arrays and time arrays and such things. We'll look a wee bit deeper at them in a short while. And there's also these data files. These are Geo2D arrays, which means that they can represent data, for example, in a map. So it's geographical data. Here we have a plotted version of the data. As you can see, it's plotted in the map. And if you've ever been in Helsinki, it's clear to see that it's a Helsinki metropolitan area. These blue areas are less polluted areas, and the bigger roads are clearly visible in the data because, well, they're more polluted than the rest of the area. But this is just a plot of data and no map tiles or anything like that behind it. Then we have another screen which displays the data, raw data in the file. Here we have our longitude array, which describes the longitude, and here's the latitude, and we can see for example in this longitude and latitude the air quality is 1.2, and we also have one interesting parameter here, and at the bottom bar, which describes the time index, and we have a selected time index 1, which means this point of time.
Yeah, and now we can take a closer look at the Enfuser data format. We already saw that the file is netcdf, but how the Enfuser uses that format. The data is expressed through variables which describe their own data type, their unit, and also their relations to other variables. There are a couple important ones like time, which is a variable that describes time from some moment on forward. So the unit could be hours since some moment in time. We also have a code example for using Enfuser time variables.
All right. So now we get to look at the code. There's a Java example, as I said earlier. All examples will be in Java, but this should be quite similar in any language. Here we have a main method, which is the entry point for this example. The first thing we do here is to load the file. It's just file.nc, but it could be any of the Enfuser provided files. It's just a constructor where you call it netcdf file.open, and it opens the file. Please note that this is auto-closable, so it means that in the end of the example it will close itself, but this is a really necessary step. But the reading of time, we have defined that we are interested in fourth time index. Please note that Panoply starts from 1. So first index is 1, and in Java code it's 0. So 0 is the first time. So in for example, Panoply, this would be time index 5. This is just a print. So let's see how we really obtain the time. First thing we need is to look up the time variable. It's rather easy. Just from the netcdf file, we call the find variable method, and it returns a variable instance for us. So here we have a time variable. The next thing we do is to read the data from the variable. Variable only describes how the data is stored, and the array itself, of course, stores the data. It's integer, as we could see in the Panoply. It's typed as an integer and one-dimensional array. So we read it by providing null as a starting point. So it means that it starts from the beginning, and the shape of the variable. In the time array, it's always, I know that it's going to be array of 25 cells, because 12 hours past and 12 hours to the future, and 1 in the for the present. But anyway, we use the time variable's shape because it's much easier and future-proof method to read the file. This is well, and another thing, it's just 25 cells, so it's not that important to optimize anyway. So we are going to read the whole array. This would be a problem for bigger data sets, but it's okay for so small set. So I left it to read all the data just for the simplify the example. Then the next thing we do is parse the date unit from the variable. The variable itself describes the unit, how it should be interpreted. For example, time can be parsed using date unit class, and the variable itself has a string that contains how the time is represented in the data file. So we read that, and then we have a utility to make a date out of the value. So and finally we just create a offset date time, so it's easier to display for you. Let's try that out. So here it says that 4th time in this equals this point of time. Rather simple.
Another important variable is latitude and longitude, which are stored as a one-dimensional arrays. They describe coordinates, and these coordinate indices can be later used to get the actual air quality data. We also have code example for latitude and longitude data.
Right. It's quite similar to the time variable example, so I skip all the similar parts and go straight to the main method. This time we are asking for two different variables, or well, 2 different indices, latitude index and the longitude index, and we also print them out at the end of the example. Let's look at the get latitude method, or get lat for short. As with the time, we started by finding the latitude variable, And then we read the whole array as a one-dimensional float array. This is not int, but float, so it's different data type, but the principle is quite the same. We also read the whole array here. It's a couple of thousand cells, so it could be worth optimizing, but we didn't do that in this example. But now we know how to interpret the value, because it's just a float. It's just a value which describes the latitude, and it can be represented in floating point variables. So it's just very easy just to read the value from the array and return it. And we do the same for latitude and longitude, obviously, and then just print them out. Let's try that out. All right, here it says that index 8 is 60.133 and 4 is 24.58 and so forth. If we would change these parameters to something else, it would change the outcome like this.
And now the actual data. Also, there is the multi-dimensional arrays. These previous examples have all been single-dimensional arrays, but then there is the actual air quality index and also all the components, the actual pollutants that can be measured. So the data file actually contains the air quality index and also all the pollutants used to calculate the index. Data arrays can be accessed using the indices of the previous arrays that we show you. We can also take a look at the slide 10, that was the actual viewing panoply. So it maybe shows you a little bit better that we have the index of air quality, and where it is formed, this is a time, latitude, and longitude. So we need to use the indices from the time array, latitude array, and longitude array to get one measurement of the actual air quality data from single point in time, from single location. And we have obviously a code example for that also.
Just a moment. I think it's time to take a look at another example first. The netcdf file contains variables, but they are not very tightly defined. So, for example, in Enfuser's data, they have lots of different variable names, and luckily the file describes the variable names, and but we don't know which one is which without looking at them. So that's why I brought this little example how to get all the variables from the netcdf file. It's rather straightforward. It just the main file just reads the file, reads the variables, reads the short name. Variables always have a short name, which is kind of used to program programs, and display name or long name to describe the variable to humans. But anyway, we print out the short name because we are really interested in that, because we are reading the variables with code. So let's try it out. It prints out that we have time, CRS, coordinate reference system, latitude, longitude, and index of air quality, time, age, time bounds, mass concentration of nitrogen dioxide in the air, and ozone and so forth. But these are the actual values you need to use. So if you just ask for example, air quality, you would get nothing. So you would need to look up which is the correct parameter for the component you are interested in. And we have noticed that these have at least once in time have been changed. The air quality was just AQI. Now it's index of air quality and so forth. So you need to be a little bit careful and not to hard code anything. It needs to be configurable. But anyway, just a side note to the actual data array example. This is pretty much the same as the previous examples. It opens the file and so forth, so I skip that. And now we have 3 indices what we are interested in: the time index, the latitude index, the longitude index. And these are just copied from the previous examples. So get time, get latitude, get longitude, they are all the same methods. So I won't dig any deeper right now, but we have a new method called get component value. And as you can see, it uses the index of air quality 194, which is exactly the same as in the previous print variables example. So here we are reading the data array of the air quality index. We give the time, latitude, and longitude index as parameters to the method, so we can configure them. And the reading is still quite straightforward. We look up the variable. It's still variable, and it still describes itself. But this time it's array float D3, which means that it's a 3-dimensional float array. And now we just need to optimize, unfortunately, because the data array is really large. It's somewhere near 2 gigabytes of total data, but of course we have 5 different components, so it's not that large. But anyway, way too much to read at one, just to read in memory in one command. It would take some time, and probably the virtual machine would run out of memory and so forth. So we specify a origin. This was in previous examples, this origin was defined as null, as we can see here in time array. Now it's time index, latitude index, and longitude index. You can see these. Well, the variable describes itself, but it's well, if you're just interested in Enfuser data, not in NetCDF in general, you can always look up from the panoply and check that the first parameter was index, the time index, second was the latitude index, and the third one was the longitude index. So this means that we are starting to read from this point in the array. And the second parameter that was in for example, time variable, it's a shape. And in this time variable, it's just an array of 25, as I told you before. And in the latitude index and longitude index, it's an array of a couple of thousand. But now it's a 3-dimensional array, which are multiplied by the total of time index plus total of multiplied by latitude index multiplied by longitude index. So it's very large, and that's why we are defining it as 1, 1, 1. So we are just interested in one value, you could of course read a larger array if you are, for example, going to plot that data or exploit it somewhere. But for the example, we are getting just a small subset, which is just one float, and then we can retrieve it by defining that we want first cell from that array that obviously produces a one by one 3D array, which you can access by using one 0 indexes, of course. And then we have a complete value, and here we assign it to AQI variable and print it out. Let's try how that works. Like this. So it says the air quality index is 2 at that point of time at latitude and longitude. So as you can see, you always need to access the data via the indices, not by, for example, latitude or longitude value. If you need to look up, for example, all values in some longitude, you need to first resolve, do a kind of reverse of what we are doing here. So to look up closest index for the specified longitude and specified latitude, and of course specified time. You can, of course, just try to switch some of the parameters and see if the result changes. It should. It's 1.7 in another time and in another place, so it changes. And we could check that it's the same value that in Panoply, which is, well, it kind of is because it's read from the same file.
Now, when we know how to get the air quality data from the air quality data file, we should somehow know what it means, because we will only get value. I can actually show this table here. So this table shows how the actual air quality relates to the other measurable components. So if the air quality index is below 2, air quality is very good. It means that these all other values are below this one. Air quality is calculated so that you actually calculate the air quality index separately for each component that is used, so for each measurable pollutant, and then you choose the highest one. So, and then there is the other categories. For example, air quality index from 2 to 3 is satisfactory, from 3 to 4 is fair, and so on. Above 5 is very poor. We can see that what it means in actual pollutants here. So for example, above 200 micrograms per square meter is the small particles size 10 nanometers, I think, then we will have very poor air quality. You can also have some more information from the Finnish Meteorological Institute site if you are interested more deeply how this actual measurements and predictions are made.
The air quality index is in Finland. It's from 1 to 5, but it's not a standard way of measuring the air quality or displaying the air quality. I think that the most commonly used standard for representing the air quality is the color. So that's why we have a color this table. So it's always green is good and violet is not that good. That's horrible air quality. In fact, very poor. So you need to scale up if if your system uses from 1 to 100, 1 to 200 and something like that, it needs to be scaled up. But the equality in Enfuser is floating point values, so it's easy to scale up. And of course there are a lot of other air pollutants available, but these are the only ones that Enfuser publishes. And the Finnish Meteorological Institute does have another pollutant sources, but they are from the sensor data, not from the Enfuser, which is calculated and a very dense grid of data. So these are the only ones we currently have.
And all this material that we have showed you, the presentation, the code examples are available in these addresses, and I think that also the recorded presentation will be available afterwards.
Yes, I think that where it will be shared is going to be somewhere in the internet, but I don't know yet where. All right, as we told you before, we have left some time for questions.
Actually, quite a fair amount, so hopefully there is some. The file by purpose we left it out because it's quite large. It's about 2 gigabytes, the file, but like we showed you earlier, we can maybe go back to that slide. You can download the Enfuser data from the Finnish Meteorological Institute's website.
Okay.
Because it's not a code, it's an actual data file. So we didn't put the 2 gigabytes data file to GitHub because then the cloning of the repository will take forever, and then the data is not relevant for a very long time. It is only for 24 hours.
If you don't want to download 2 gigabytes of data, you can always use these download parameters to limit the size of the download. So you can, for example, if you're not interested in CO2 or something like that, for example, the components, you can specify that you will download only the air quality index, which is the calculated version of the air quality. And you can also use the bbox parameter to limit the size of the area and map which is involved, and it also could dramatically reduce the size of the file.
We can maybe show again how the download, how you can actually download the data. So from the presentation, we have the link.
Well, the library itself supports it, but the Enfuser can be quite slow at some times, so it will take some time to download. So we thought it would be just easier to download the file as a complete file and then read it afterwards as a separate process. We actually used cron tab just to download the file.
And of course, you can write code that downloads the file and then access it. But if you have some more faster data source, the Finnish Meteorological Institute's open data site is sometimes quite slow, so it's not very good idea to read straight from the URL, but it is possible. But if you have some more real-time or more faster data source, then it's okay. I think that it happens quite similarly as open the file. You just provided the actual URL. But will we still show because the downloading is, in my opinion, a little bit tricky process.
Yep, it is.
Because first you have this Finnish Meteorological Institute's data catalog, and then it shows the VFS service, which you should open. Then there is the metadata of that file as a XML, but what you're actually interested in is the file reference element.
This is here in the middle of file. Of course, you can download this VFS file. This is just a small XML file. So and look up the file reference from there programmatically. And well, I suggest that you do that, of course, because the parameters change all the time. Well, not all the time. That is start time and end time and so forth. Or you can just use the URL and decipher your own start time and end time and so forth.
Yeah, so these are the parameters that we were talking about that you can provide. So you can give the origin time, start time, end time format. So you cannot change the format, at least in this scope. It has to be the netcdf, and projection has to be the what it is in that example. But you can change the bounding box, the components, and start time, origin time, and end time.
This URL contains all the possible parameters, so the components you can use. So you can look up here, from here what you really want to use.
And that is the file that you need to download to run the examples, and you need to actually rename it to file.nc. I think that the default name will be something different.
Historical pollution values. I don't think they expose the data, the historical data. So I should suggest that you download the file and store it yourself for each day.
Yeah, the file contains, I think, that 12 hours past. So you can download the data, but it not actual historical data. I think that the file contains 12 hours past, present, and 12 hours forward.
Well, don't know if FMI has published how the data is actually created, but one of the representatives said to us that it comes from sensors. There are sensors around a city which measure some components, and then there's the weather data. They use weather data to take account, for example, wind and rain and such things, that some pollutants can come from other countries, and the rain, of course, removes the pollutants from the air and binds to the ground and such thing. And there's also OpenStreetMaps data, which they use to use the city layout, so how the wind travels through the streets and moves the pollutants and so forth. And they also have the height data of all buildings, so they also use that somehow. But unfortunately, we have not seen how this Enfuser data is actually calculated.
Yeah, I think the actual mathematical model behind of calculating the data is actually very, very complex. And it's not, I think that it's not public knowledge how it works. At least we don't have it.
Unfortunately, that is not something we know, the precise data sources, but FMI publishes a lot of data. So I think that all the raw sensor data can be read via the opendata.fmi.fi, or their catalog service, and also downloaded but found via the service. So I think you can find the raw data, the sensor data from FMI.
I don't know if they use traffic data. We can open the link that was in the presentation. That is the service that the Finnish Meteorological Institute provides. So there is at least this picture that shows what kind of data they use to make these calculations. But we don't know the actual details on these sources, that where they come from. It's something that needs to be forwarded to the Finnish Meteorological Institute.
Well, I think it's doable. Well, you need quite many sensors because the Enfuser is, of course, it's mathematical model, so it creates a lot of data. But as you said before, it's not actually actual data, actual measurements. It's calculated measurements, which are calculated in different sources from different sources, and can be wrong, and I think it should be validated, but you would need a lot of sensors to do that. So, or another possibility is to validate just a small parts of the city and check if it actually is correct or not correct. The Enfusion's evaluation of the air quality. But I think you can use actual sensor data to correct Enfuser's models. So if you do have such sensors around the city, it could vastly improve the Enfuser's model. Well, for me, I think it's the slowness.
Yeah, and I think that the amount of data, so it causes in some point it causes some need for quite high processing power if you want to, for example, process all the data provided by the Enfuser, because there is a lot of it.
Yeah, basically just a lot of data. But if you split it to smaller files and use a lot of power to analyze it, it's of course doable. But that's the main challenge. The origin time, well, they basically it's a midnight on the current day. Usually the origin time, and all the it means that all the predictions that how polluted the air will be are well compared to that time frame. So and the time variable starts from there. So if you are using the time in this index 0, it's the origin time, and it's always the same, and you can limit your amount of data you get by using the start time and end time. So it doesn't give you all the data from all the times, but just a small slice. But the origin time is always the same. Of course, it updates daily because all the predictions are related to current date.
Yeah, origin time kind of means when the file was somehow produced, or when it was produced, or from which point in time it was produced. So it kind of identifies the file, and then the start and end time is the parameter from that file.
Yes, but the file itself is updated hourly because the predictions are getting better, of course, when if we are, for example, past that time, then we actually know how much it was, how polluted the air was in some point. It's not the prediction; it's a current time. almost everything is open source. There's one project that contained some formulas about how to calculate the AQI, and it was not open data, so we couldn't publish it, but everything else actually is open source. Most of the work we did is to Open Trip Planner, which is a routing system, open source routing system, and in that we read the netcdf file and modified the graph data so that users can query about the cleanest possible route through point from A to B, and of course to the because we were creating that clean air routing system. Another project is related to NGSI, which is a format for publishing sensor data via the internet, and the Enfuser has so much data that you cannot use the existing servers. They don't. Well, it's JSON API, the NGSI, so it's almost impossible to import all the data hourly to the NGSI server. So we created a kind of wrapper that that reads the NGS file. Reads the netcdf file and publishes it as a NGSI lookalike service.
Yeah, we actually tried in some point to serialize the one netcdf file as JSON, and I think that even the single hour was something like 50 gigabytes. So the amount in JSON format is quite insane. So you should use the netcdf or some other little bit denser data format than JSON or XML.
Yeah, but that source code can be useful, but not exactly reusable in this context. I don't think that you can. Well, you can if you want, but but I don't think it's going to be very useful for you. But you can, of course, look at the code and see how we have processed the file and how we have handled everything there.
Yeah, in that project we use this kind of search engine called Elasticsearch that we use to index actually the indices from the data file and perform queries based on that. So that might be useful, and these are all available in GitHub.
I have heard of different projects that are doing exactly that, and I think there's one present at the moment in this webinar. But unfortunately, we don't work in FMI, so don't really know. But as you said, it's been around for years, and it's probably quite good. Yes, you're correct. It's not a client. It's a server. We created the Enfuser-NGSI server because, as we said before, the amount of data is really if exposed through the NGSI, it's a huge amount of data. It's almost 50 gigabytes per hour, so it's way too much to upload the data from, for example, just to download the data and convert it to NGSI model and send it to a server. So we created a kind of lookalike NGSI server, which acts as an NGSI server, but doesn't actually have all the features. For example, you cannot use it to upload your own data. It just exposes the data to NGSI compatible clients.
Yeah, I think that you should be able to use existing NGSI clients with that server, but it's something that looks like an NGSI, the Orion broker, but it's not. It is just a wrapper for the NGSA data, because the actual Orion broker, we cannot feed that much data to it, at least without some like ridiculously large machines.
Yeah, that's a wildfly cluster, so it's a Java EE program. You can scale it up quite easily, but we have one installation for the clean air routing system that the clean air routing system's UI uses to display the user how polluted a single point in their route would be. But that's nowhere near as powerful to be used worldwide. Just the UI will take all its power, but you can of course start the server yourself, and probably you need to develop it further, because well that's made only for the clean air route planner project. But well, of course you can just take the server and develop it further, and maybe fork it to your own repository. And
so there is no up and running instance of these APIs. We have to take this server and deploy it somewhere in order to have the NGSI serialization of the Enfuser's data.
Unfortunately, no. Well, really, there is one single node installation of that server, but
it is not very powerful. So if there is a lot of usage, I think that it will not be able to serve quite many clients.
But of course, it could be scaled up by bigger machines and that create a cluster, and then we would have such interface. But currently, no.